Today, we're diving deep into the world of quantum technologies. This stuff used to be pure science fiction, but now it's becoming a powerful new reality, one that's getting ready to completely reshape entire industries and unlock scientific breakthroughs we've only dreamed of. So let's get right into it.
So let's start with a big question. Think about the gnarliest challenges we face. I'm talking about things like designing brand new medicines, molecule by molecule, or creating truly unbreakable codes, or even trying to optimize a global supply chain in real time. Our current supercomputers, as powerful as they just hit a wall. The complexity is just off the charts.
And that's exactly where this new paradigm comes into play. See, quantum technologies are being built right now to take on these unsolvable problems. We're moving from chalkboard theory to actual hardware. And it's not about just making our current computers faster. No, this is about building a totally different kind of machine from the ground up.
So what does this next computing revolution actually look like? Well, you can think of it as standing on three main pillars, each one promising to change our world in a pretty profound way.
First up, you've got quantum computing itself. We're talking massive, exponential speedups for very specific, very thorny problems. Second, there's quantum sensing. This gives us the ability to measure things with a precision we've just never had before, everything from tiny signals in our brains to faint ripples in spacetime. And third, you have quantum communication, which is opening up totally new ways to send information that are, by the laws of physics, completely secure.
Okay, so to really get how any of this is even possible, we gotta pop the hood and take a look at the strange and frankly wonderful mechanics that make this quantum engine run. Everything, and I mean everything, starts with the qubit. Your computer, your phone, they all use bits. A bit is simple. It's either a 0 or a 1, on or off. But a quantum bit or qubit, it can be a 0, it can be a 1, or it can be a mix of both at the very same time. And that one little difference is the source of all its incredible power.
Now, that mind-bending ability to be both 0 and 1 simultaneously, that's a property called superposition. And because qubits can hold multiple values at once, a quantum computer can explore a huge, huge number of possibilities all in parallel. It gives it an unbelievable advantage for solving certain kinds of problems.
And then things get even weirder with entanglement. This is a concept that was so bizarre, even Einstein called it spooky action at a distance. Imagine you have two magical coins that are linked together. You give one to a friend who travels to the other side of the universe. The second you flip your coin and see that it landed on heads, you know instantly that your friend's coin landed on tails. That deep, spooky connection is a fundamental resource for quantum computing.
Now, you might think there's just one way to build a quantum computer, but nope. We're actually in this really fascinating, wide-open phase with a bunch of different approaches competing. For instance, you have superconducting circuits. This is what folks like Google and IBM use. They're super fast, but you have to cool them down to temperatures colder than deep space. Then you have trapped ions, which are incredibly precise, but making them bigger is a huge challenge. There's also photonics, which uses light and can run at room temperature, and neutral atoms, which are awesome for simulations. Each one has its own pros and cons, and honestly, the race is on to see which design, or maybe some kind of hybrid, is going to come out on top. This whole scientific race isn't just happening in a few isolated labs. It is a full-blown global phenomenon. And that brings us to our next section, mapping this incredible explosion of innovation, competition, and, yeah, even collaboration that's happening all around the planet. Just look at this timeline. It tells the story perfectly. For years, quantum was mostly academic, so patent activity was kind of low and steady. But then, around 2014, something kicks into high gear. You see this sharp acceleration, and by 2018, filings go absolutely exponential. That's the signal. That's when you know big money and serious R&D from companies and governments started pouring in. So who's leading the pack? Well, if we look at what are called international patent families, these are the really high-value inventions that get protected in multiple countries. The United States has the lead, with about 31%. But it is not a runaway lead. China and Japan are right there, neck and neck, and Europe is a major force too. The real takeaway here is that quantum innovation is happening everywhere. It's a truly global field. But here's the fascinating twist. For all the talk of competition, the quantum world is also deeply interconnected. This chart shows this amazing web of international collaboration. You've got researchers and companies working together across all kinds of borders. The link between the US and the UK is really strong. But you also see these crucial partnerships involving the US, China, Germany, Japan,
you name it. And of course, this global web of innovation isn't running on air. It's being fueled by absolutely massive investments, both private and public. So, where's all this money coming from? And what can it tell us about the state of the quantum economy today? Get this. Over the last decade alone, the core companies in the quantum space have pulled in more than $20 billion in funding. I mean, that is just a huge vote of confidence from investors who are betting that this technology is right on the edge of a massive breakthrough. And the trend line for that investment tells a really interesting story. You had this steady growth for years, and then boom, a massive, massive peak in 2021. Since then, the market's cooled off a bit. Things have come down from that crazy high. But what's really important is that the number of companies getting funding has stayed pretty stable. That suggests the whole ecosystem is maturing, right? It's moving past the initial hype and settling into a more sustainable long-term growth phase. Okay, so we've talked about the wild science, the global race, the billions in investment. But what's the point? Why does any of this matter to us in the real world? Well, the impact is going to be felt everywhere, but let's just zoom in on one incredible example. Medicine. Seriously, quantum computing could completely revolutionize biopharma. It could let us simulate molecules with perfect accuracy to design new life-saving drugs faster than we ever thought possible. It could help optimize clinical trials by finding the exact right patients for a new therapy. It could unlock true personalized medicine by crunching these vast, complex sets of genomic data. And these new quantum sensors could lead to medical imaging tools that are straight out of a sci-fi movie. And this isn't just wishful thinking. The industry is paying very close attention. In fact, surveys show that about a third of biopharma companies are already early adopters. They're actively working on this now. Another 44% are what you'd call the early majority, basically getting their plans ready to jump in as soon as the tech is proven. So this isn't some distant dream. It's already part of their strategic planning today. Okay, but before we wrap up, it's so important to understand one key point. Quantum computers are not going to replace your laptop or your smartphone. They are different tools for different jobs. Your classical computer is a fantastic all-purpose problem solver. A quantum computer is more like a specialized superaccelerator, designed to absolutely crush a narrow but critical set of problems that are impossible for any other machine on Earth. The science is pushing forward, the money is flowing, and entire industries are getting ready. The quantum future isn't something that's decades away. It's being assembled right now, qubit by qubit, in labs and startups all over the world. Which really just leaves us with one final, crucial question to think about. Are we ready for it?